So I think most of you have seen the topic would discuss more about the DICOM standard, healthcare standard, and the medical devices. My name is Ajay Pratap Singh, and just a disclaimer that this presentation does not reflect any opinion or data from my employer, and whatever I present here is solely on, on my behalf, or every data is mine. So, and most of the, because healthcare data is, is very important. So most of the data that I'll be showing here is either fake, or if anything sensitive is there, then I have hide that part. So yeah. So who am I? I'm a product security specialist at Philips, where my goal is to secure medical devices. I have got privileges to speak at some other conferences like Nalkun Kukun, and definitely HITB got me this pleasure as well. So I don't call myself a hacker, I'm just a bug hunter. So I just trying to find some bugs. And I like to play cricket. Who else likes to play cricket? Somebody? Oh, cool. And yeah, that's my Twitter handle. So before let's see what will be the today's agenda. We'll talk about healthcare security, then we'll go over the DICOM, then we'll understand standard workflow, information model, network communication model services, then DICOM attacks, of course, the methodology to pen test medical devices and systems, and security in DICOM, and then at last we'll conclude our presentation with how to secure these things. Yes, so this question is for you guys. What do you think of healthcare security? Anybody working in healthcare domain? Cool. So I think you should give me the answers why healthcare security is important. Yes. One more reason. Yes. So that comes into the medical devices part. So one more part is the data in healthcare security is persistent data. It is, I would say, it's a permanent data. So if your healthcare information is compromised somehow, so it contains your name, information about you. In some cases, if we talk about the other standards, contains your address, your SSN number if you are based out of US. So these information are persistent. Once stolen, it's very hard to change. Anybody has changed a SSN number? I think you might have not heard about it, right? Changing. Why it is important more than financial data? Because once your credit card is stolen, you can get another credit card within few seconds. You can block the credit card within few seconds, just you need to make a call. But changing your personal information is a bit hard. That is why the data over here is very critical. So let's see how big is the healthcare industry. If you talk about, it is expected to be $11 trillion by 2020 healthcare industry. And the healthcare technology sector is estimated to be $280 billion by 2021. And USA GDP percentage on healthcare is 17.9 in 2019. So you see, it is being calculated in the percentage that too of a country's GDP. Now, why security is important? One answer we gave it, right? What are the other things you can do with the healthcare data? Just a blind answer. If you have healthcare data, what you can do? I'm sorry? Blackmail on the basis of what? Yes, one of the reason, if you see many of the people don't want their disease to be disclosed, that's correct. It is a embarrassing thing for some people, but there are many other important things which can be done by the attacker. Identity theft. If you have all the details of a patient, name, address, his age, date of birth, everything. So identity theft would be very easy. Patient life, as you said. So that is why I have highlighted this as well. So if you see, the technology in the healthcare sector has changed the healthcare sector fully, the technology part. So if you see, almost every technology nowadays is being used in healthcare sector, even AI or blockchain, people are thinking of using it. So if you are using too much technology, then definitely technology are vulnerable to cyber attacks, right? So if you have let me give you an example of a ventilator. So if you have a ventilator that makes use of, let's say, Bluetooth or Wi-Fi wireless technology to transfer the data to the mobile application, then you see if ventilator is used generally to stabilize the patient, right? Before giving any medication. So if a patient is over there and somehow you hacked into the ventilator or you turned off the ventilator, you perform DOS attack or any kind of attack, then the patient is no more. What will you be doing with the data when patient is not there, right? So that is why the patient life is very crucial. Financial frauds, of course, if you have details of the patient, then it's very obvious. There are cases where it is being used for insurance purposes. So they claim the fraud insurance, got the money because you have all the details of the patient. You just need to create the fake documents, right? Of course, access to unauthorized medicine. There are some medicines which you cannot get without prescription. If you have the data, you can you can create the fake prescription, and you can get hold on to the medicines which are not you will not get. Generally, like sleeping pills, you will not get, right, without prescription. So these are the things. Yeah. So this is the healthcare industry, or I would say, yeah. Let's go ahead and talk about the healthcare standard. So DICOM. So DICOM is a healthcare industry standard in the imaging modalities, which is being used for transmit, store, retrieve, print, process, any for an information in imaging devices. Yeah. So when I say imaging devices, it's like which creates or handles the imaging data, like X-ray machine, ultrasound machines, MR machines. So DICOM is a standard. So before going to the DICOM, let me just say why it came up. So initially, if you see, let's go back some decades back, people were facing problems. So when one company designs equipment, they have their own language to communicate. If another company designing another equipment, the same equipment or the equipment related to that, they have different language to communicate. So the problem was, if one hospital has, let's say, Philips devices, and another device is of any other company like GE, Siemens, then the communication was the barrier, right? They cannot communicate. The interoperability, we say that in a technical term. So that is when the DICOM came up, right? So DICOM came into the picture to provide interoperability between devices from multiple manufacturers. So yeah, so DICOM is also used in networking protocols like modality. So when I say modality, it's like one machine, like X-ray, ultrasound machine. In technical terms, it is called modalities. You have a PAC server. So PAC server is an image archiving server. You take the image, you send it to one place. That is called the PAC servers. Now, how DICOM file generally looked like? So this is a high level format of DICOM file, where you have a first is preamble, then suffix, then you have a data elements, multiple data elements. This is useful when we talk about one of a kind of attack. So the three things that needs to be remembered here is the preamble, that is generally 128 bytes, prefix 4 bytes, and the other data elements that contains the attributes, the tags, and of course the image. So we know that it is being used in hospitals for imaging devices. Then let's see how's the workflow of this in the hospital. So let's say a patient comes in, it goes to the registration guy or a girl, whoever is there, they take the patient information, they create one kind of order. So that comes with the HL7 ADT. HL7 is another healthcare standard which does not deal in the imaging directly, but the other kind of data like your name and these kind of data, names, address, the registration, you give your details, right? Those details are sent using HL7 ADT messages. Then after it goes to one of kind of modality RAS or scheduling purpose. So when a patient comes, it might say, okay, I am having this problem, that problem. So based on that, it will be assigned to one doctor. Doctor will see, okay, this kind of, because the registration person doesn't know. They are there just to take the patient information. Then it has to go to one doctor where they see, okay, the patient is having this kind of problem. I think we need to take X-ray for this patient, or ultrasound, or some other things. So after analyzing the patient, the doctor schedule, let's say the X-ray. Then it goes to the modality automatically. So You might have seen in the hospital that when you go to the registration, the person says you need to go to room number this. They never take your documents, right? Because the information flow directly. You don't need to take any documents and all, generally. So from the modality, person will get to know that somebody will come for the X-ray. The X-ray will be taken and it will be sent to the PAC server where all the images are stored. So at the modality or the technician, he needs to make sure that the image is taken correctly. There is no problem in the image, and after that the image will be stored into the PAC server. And from PAC server, doctor may call it, or the radiologist may call it for analysis or for diagnosis purposes. Below are some of the full forms of other standards and some PAC server information model. Yeah. So this is how the workflow of the DICOM works. So is it understandable? It's cool. Yeah. So let's say DICOM uses and file view. So DICOM is used in imaging modalities and files with .dcm extensions. Most commonly used port is 104. Modalities based on the queries needs to be pre-configured with IP address, port number, and AE title. AE title, I will tell you what is. It's generally an application entity title. So when data is coming from one modality to the PAC server or going to the doctor's station, workstation, then the PAC server needs to know what kind of data it is, to which machine it belongs to, whether CT, ultrasound, or MRI machine. So this information is in AE title. So based on the AE title, the PAC server will verify, okay, this is the CT image and I need to store it over there. Yeah. So this is how the DICOM file looks like. So mainly we are dealing with data, right? We are more concerned about the data. Can you look at the image and tell me what is the sensitive information is over there? How the information, just, I think it's right there. Follow the tags. Yes. Yeah. Yeah, it's the personal information about the patient, and which is very crucial. I think in all the, like if I talk about HIPAA or GDPR in European Union right now, you cannot reveal this information. Otherwise, the GDPR fine is 4% of the, total revenue, or the $20 million, whichever is higher. So right now you might have seen some companies were also fined after violating the GDPR. Yes. So this is how it looks like. So if you see, these are DICOM text at the right hand side, which contains the information. So the information is divided in certain attributes, IOM, IOD. So this is the DICOM information model, where you have the attributes, which includes name, ID, tag, etc. Now the collection of, the logical grouping of these attributes is called IOM, which is called information object module. Now when you combine the information object module, it will become a information entity. And when you combine all the information entity and everything, it will become a information object definition. That is called, it's like an image, like X-ray image and all. Now furthermore, this IOD is divided into two components, that is the composite and normalized IOD. So which based on the operation or the kind of service they provide based on that. So now if you see, the IOD is generally a collection of data. Now when, when two modalities or system talks, how they will get to know that what kind of data, needs to be shared. The semantics, I would say, the transfer syntax, that is decided based on the SOP. So if a modality, city modality is sharing the data with the PAC server or sending to another system, they should know what kind of semantics being followed over there, right? Because it provides, so as I said, DICOM is a healthcare standard which provide a common way to communicate, right? So you need to know what kind of information will be coming to me. That will be decided by the SOP class. So SOP class is it's a combination of services. Services means what kind of operation you want to do. Like you want to store the image, you want to retrieve the image, you want to move the image. And of course the IOD, what kind of data it contains. Defines the type of information stored with service associated, right? and it is always identified by the one unique ID. So it has SOAP class UID, which has a specific number like 1.1.001. So when this number goes to the receiving end, it gets to know that the information that I'll be getting is a city or MR, and based on that, it it selects the transfer syntax, right? When you do the negotiation or other kind of stuff, you need to negotiate. I will be giving you this kind of data, whether you understand it or not, right? So it's the same semantics that has to be negotiated between two entities. And at least one SOP for each modality should be there, right? So we discuss about what is DICOM, how it flows, how the data is collected. Let's talk how the network communication is. So in OSI model, if we talk about, you have a client and server, right? In DICOM, it is called SCU and SCP, service class user, service class provider. SCU is the client, SCP is the server. Before they communicate, they do the association. Association, like I just said, that I will be sending you this kind of data. Do you understand this or not? Or it might say, hey, I speak English, Italian, French. In a layman, I'm saying, I speak these kind of languages. Which one do you understand? They might reply, okay, I understand English. Let's communicate. Send me the data. So the actual data is always transferred after the successful association. What things that needs to be done for a proper communication are the AE title, IP address, and port number. These are the main things. Now, DICOM provided certain kind of services, as I said to you, that the kind of operation that will be done, it is based on the services. That is again the two kind of services, composite and normalized. So the services related to the composite IOD, as I just explained, will be handled by the composite services, and the the normalized IODs will be handled by the normalized services. So if you see this C echo, C find, C store, these are kind of, you could say queries, you could say it's a kind of commands as well. So C find is like, if I want to have any information about the patient, I will go to the server, I'll say, hey, do you have this guy? If I C echo is actually a kind of ping request, but not a ping. So it is generally being used to see whether the system is alive or not, whether it can be associated or not, but it does not work in actual ping way. Because if you have enabled SSL and you are trying to communicate without having the SSL certificate, the ping will fail, the C echo will fail, and it will not associate. So in that way, it is a bit different. Now, do you have normalized services? It generally deals with the storage commitment. Storage commitment means you have a X-ray machine, you take the image, you want to store it. Now you want to be sure that the image is stored properly. So you say to the server that I need the commitment. So in that purpose, then these kind of queries are being used. And of course, the print management. You want to print the X-ray or the MRI machine on a film, then these kind of services are used. One thing is very important here is that composite service does not provide any delete option. So it is specifically it is intentionally been taken that whatever image you take and you should not perform any delete operation on those. But because the normalized service are just to provide support to the composite services in layman, so these are generally have the end delete option. Like once the task is done, I print the film and I don't need to go further, then delete the task. Yes. So let's see how it looks like in Wireshark. So if you see, the very first request is always associate. Then after that, it sends the actual data. And if you see in the C find, the response contains the patient data. If you see, it says a patient, birth name, time, name, and everything. And these are the, the column in green. It's the tags. They are also defined. So if you go over a Google and you just type these number, it will give you the exact number. So if you see the patient ID is 00100020 hex format. So it is specifically meant for patient ID, right? So when the information goes from one end to another end, that end should understand that the information that I am getting is a patient ID. That will be identified based on these tags. If you talk about the C storage, if you see the highlighted is C storage, city image storage. So it contains the data, again the patient information, and it also has the images, which if you go to the Wireshark, just go to the file and export the image in DICOM format, you will directly get .dcm file. I will show one demo of that also. So I think it's clear how the DICOM is implemented, what is the workflow in the hospital, what is the networking thing, what kind of data it contains. So what do you think, what are the attack vectors you see? What do you need actually to attack these things? There were three things that were very important. When I was saying, yeah. Mm-hmm. Yep. Yeah. Mm-hmm. Yep. Okay. So showdown one is the correct one of the correct answer. So if you go over showdown, what will you be searching for? So there are mainly three things apart from showdown, but three things you need to have for certain kind of attacks. That is these things: IP address, port number, and AE title. So AE title is used to identify, as I said earlier, it is generally being used to identify DICOM application to other DICOM application on the network. So these are the three things. Now, most attacks that happens on this standard is basically due to the missing of the SSL communication or certificate based communication. Why these attacks are there originally at the place, that is very important. It is because DICOM is a standard. That is, actually I should have shared this earlier, but DICOM is a standard. It is not meant for any security things. It is just provide the interoperability between the devices. That is the main reason of DICOM standard. And it does not provide any kind of specification. Means they might say that you need to have authentication authorization, but it does not provide any kind of component or the packages which you say you need to use this for communication or for the secure, to make the DICOM more secure. It is always given to the end user or the user of the product to implement it securely, or you need to secure the data in the hospital or wherever you are using these things. So that is very important thing that needs to be understood, that it's a standard, and the implementation also depends upon the owner of the product, how they want to use it. I have got the CT scan machine. They might say the machines always provide a facility to have the secure communication and all, but I see the hospital says, okay, why I need to waste money on having a expensive certificate and all. It always to the owner of the product, how they want to implement it. Then DICOM attacks. So if you don't have SSL, what is the most common kind of attack that you can have? Very basic. First one, the man in the middle attack and sniffing. What kind of information you can get? There are two kind of attack that you can perform. Firstly, you will get to know who is the sender, who is the receiver. Based on the AE title can be custom one, but based on that you can identify what kind of data is going from which modality or to which server, or what is the server over there, right? Indirectly, if I would say, you will get to know the infrastructure inside the hospital, that I have this machine, this kind of data going, this kind of data going, right? Next one is the P-DICOM attack. So it was recently released by Markel Picardo Ortiz from Celera Labs. So as I said to you earlier, shown this DICOM image, right? DICOM file format or the packet format, which had the preamble, prefix, then the data elements. So what they did, P is a portable executable, which is executable file in Windows file system for 32-bit and 64-bit operating systems. And they have a particular format. They also has headers and the way it execute based on some information. So what they did, in a legitimate DICOM file, they inserted any malicious executable file. And how they did that? Did that based on the preamble. So preamble is generally 128-bit. Instead of that, they inserted the DOS or if you see the dark gray one as the actually the programmable executable file content. So first is the header, then again DICOM elements came, which is prefix and other things. Then again they inserted P header, optional header, data directory, section header, and other data related to the executable file and the other DICOM file. The beauty of this attack is it does not, it does not manipulate the DICOM file in any way. So if you have a .dcm file, you will never get to know whether it is malicious or not until unless you are you explicitly doing some kind of stuff to know about the malicious file. So if you open this file with a normal DICOM viewer, it will open perfectly fine. There is no problem. But if you change the DICOM extension to .exe, it will be executed as an executable, and the malicious code inside the file will be executed. The second thing is, if you are opening the .dcm file in which the malicious file is there, be executable, and if you are opening through command prompt, it will execute as a Windows binary. Again, the attack will be successful. But if you are using PowerShell, it does not. You have to use the command line. So if you see, it's a normal .dcm file. If you have the any DICOM viewer, there is no problem at all, and it will open perfectly fine. So this is the thing. Now the next attack is, you have the IP address, you have the port number, you have the AE title. What you need to do? You need to just have any garbage file, and you just need to flood the PAC server. So storage in hospitals is one of the concern as well, because they need to take multiple X-ray, multiple ultrasound, and they need to store it somewhere, right? So if you flood the PAC server with a garbage data, it's a very big problem for the hospitals. So this is one of the, and because it does not have any kind of authorization or SSL based communication, whatever data you send, it will be accepted. The next one is, when you perform the man-in-the-middle attack, you got the DICOM file, right? You modified the data. Modified the data, I mean to say, you modified the pixels, you modify the image. Image is not correct. Doctor might, if a patient has cancer cell or doesn't have cancer cell, you can add it or delete those. Now the problem with this one is, firstly, the diagnosis. If you don't have anything, you got the you get that you have cancer, then the patient will be very much terrified, right? Somebody will get to know that this is this disease you have. So there's one more problem. The second main problem is exposure to radiation. You have the machine, this X-ray, MRI, they releases the radiation. So again and again, you are being exposed to the radiation if your file is modified, right? It's again a more concern on the patient health. So can you tell me which is the machine which does not release the radiation? Generally used on pregnant women. Ultrasound, yeah. So it does not release any radiation, that is why it is generally used. Yeah. So when I was doing my research on DICOM, I used Shodan as you said, and I found, I searched for 104 port. I see there were many machines which were available online. In one of the machine I tried to connect. So I think I have not revealed any sensitive information. I have hide that. So I have the calling AE title, called AE title calling, and the IP address which I have hidden because it's a public IP address, and it might be belonging to some hospital or a research R&D, I'm not sure. So what kind of information I got from there? This one. It was simple plug and play. Right? So you have a patient name, patient ID, then again the other sensitive information about the patient. So which generally should not be revealed. So there are, I have made few demos using the PyNet DICOM library, which is open source, because I cannot show you any live demos or any demos that has been done on the medical devices because of the compliances or regulatories. So if you talk about the regulatories, they are very stringent. I believe that the medical industry is medical industry right now is having very stringent policies or the compliances. So when we talk about internally, the FDA guys generally is asking where is your report for the pen testing of this medical devices risk analysis. Once you provide that report, they are also asking what is your plan for further steps. If the product is deployed, if any vulnerability comes, then how you go ahead and plan for this. So it's not about just you given the report, risk analysis that we have done this, we have fixed this, and the product is sold and I am fine and there's nothing to do more. They are asking more questions on medical device security, how you are maintaining it, how you are doing it, and what is your future plans. So it is very highly regulated. Let's show you some of the demos. So in one of the hospitals where my friend's mother went, she had some knee problems. She went over there. She asked the when she went for the knee surgery and all. There is one more document that they let you sign. That is the consent that this information will be used for educational purposes in the colleges, so that in colleges more research can happen. But they also provide the disclaimer that the personal information about the patient will not be shared. To which this belongs to, like image, if you have a knee surgery, you found something, then you say, okay, we have a patient, but they never reveal that information. So that is being signed right now in India also. So yeah, so these are the regulatories that are going at a very high pace, I would say. Yeah, so let's go ahead with this first demo. So it is a information, capturing, where if you are in a hospital network or somewhere else, then at the left-hand side, you see the SU, the client. Very right is the server, and in the middle, where is the Wireshark? This is the attacker's machine. So if you are in hospital network or some other network, you'll be easily able to capture the data. How and what kind of data will be looked like? Let's see. So it's a PyNet DICOM library that I'm using. So once the client sends the data to the server, you've seen the most of the data is captured in between DICOM. So in real time, if you capture using Wireshark in real time, then there is a hell lot of data in the hospital. Your Wireshark will crash in few minutes. So if you have done any pen testing on hospital-like environment that we have in our R&D, R&D. So when I captured it, within 5 minutes, my Wireshark got crashed. So this is the Wireshark file. Let's see. So this is just when I was making the videos, or so all the things what I have done, how I have done, it is all written. So yeah. Let's go ahead and any file, any packet, and just click. And if you see over here, you have the association request where your modality AE title and the PAX AE title is over there, right? So what you need to have to perform the attack: IP address, port number, and AE title. That you will simply grab just by doing a simple MITM attack, just a sniff it. You have other information. Again, these codes, if you see the DICOM application kernel, these codes are already, it's like a SOP class. So based on that, the further, the syntax, how to share the information will be negotiated. We can analyze the data, yeah. I think, yeah. So that was the thing which you can, do just to grab some information. But basically, these testing should not be done in a, you should never perform these kind of testing in a, in a real hospitals, because just because of your some experiments, someone's life is on the stake sometime. So you should always perform any kind of penetration testing or security assessment in a highly controlled environment or isolated one. So let's see another attack where we'll perform MITM and we'll try to gather some information. Or I think it's let's say, yes, we'll perform MITM, we'll get hold on to the image of DICOM file image, yeah. It's again, it's the same as the left hand one is the client, right hand one is the server. In middle, you have the attacker. It's the same. So you see, when the client sent the server the request, everything works fine. They got the data. Let me show you again. I think if you got confused. So here I clicked the left and you receive the data over there, right? Now, this is a kind of attack where we are flooding the PAX server, right? So on the basis of garbage data. We got one data file from performing the MITM attack. Or if you know the semantics of the file that is being followed inside the hospital, you can create your own. You don't need to perform MITM, but it is always the easy part. Now perform the ARP spoofing. I think you might be knowing ARP spoofing. It's just masquerading yourself as a legitimate user. So if somebody both are friends, I might say I'm your friend and send you the data. So ARP spoofing is a kind of attack, that kind of attack. You perform the ARP spoofing. It should be successful. Now the client will send the data here. I send the data I got on attacker machine. Now I will get the file. This all is the DICOM. So if this all is the DICOM communication is happening. Basically in real life, the client will be the modality and the server will be the PAC server or wherever they are sending the information or sharing the information. Now attacker got the image. They can modify the image. They can do whatever they want because it's with them, and they can send this image to the PAC server. So if you see, everything is done already. Let's go ahead a bit. Now the attacker's machine will send the data to the real PAC server. So these are the demos which gives you the high level understanding that how easy it is to perform these attacks if you are in a hospital environment, right? And these attacks are generally not only on the patient data. As I said to you earlier, these things needs to be looked into in a different way, where you should be concerned about the data, of course, but you should be, when you have the product, you should also be concerned about the patient life, that if I have a bug and that can be exploited, then it's a life-threatening thing to a patient. Do you know I think there was one high-level politician guy in US where he was having something in the heart like pacemaker, and they, okay. So they disabled that functionality because they were using the wireless technology. They disabled it because of that reason. I think the lady here knows that. So it's the simple demo. Let's go into the another demo. So it is where I will show you how to, just now you were looking at the, the sending the fake data to the PAC server or performing MITM attack, gathering information about the systems that are inside the hospital. Let's see how simple it is just to get the DICOM file over the network. So again, the same setup. You have the client, you have a server, in middle you have an attacker's machine. I'm sorry. You send the file, captured in between using the Wireshark. This is the city image you can see. And these DICOM viewers, there are certain DICOM viewers which are available free online. You don't need to, it's not like that you have to pay something for that. Open source, freely available DICOM viewers are also available. You just save the image, exported it. It's just the theory that I have written. Sorry for that. You have the intercepted.dcm file, and you just make use of any open source, available DICOM viewer. and you can open the image. You can see how easy it is just to get hold on to the sensitive patient information. Again, if you have these information, I showed you what kind of bad things that you can do, right? Yeah. Is there anything? Yeah. So if you see over here, it is all the tags like which contains the patient information, right? I have shown you the information module about the DICOM, right? So that is that part, the tags. It contains again everything: SOP classes, name, manufacturer, everything. So yeah, this is what I wanted to show you. I hope that's clear, right? About the DICOM workflow. I hope everybody understands it. So now the DICOM is done. Let's talk about the medical devices. So if you see, there are medical devices which are too much technology driven. They make use of everything, wireless technology, whatever kind of technology you have, they make use of it and try to make the product which will be the which will makes the life of billions people, or which will improve the lives of billions people on this earth. So they are making the technology for the positive effect on the health of the people, or I would say in other way, I would say the right diagnosis of the disease, or the easy diagnosis of the disease. So they are using everything. So if you see, this is page writer, and again X-ray machines, ultrasound machines. These are the like of devices that we have now. As the topic said, you need to have some methodology to pen test these devices, right? It's not the normal pen testing that you do generally on the web application, mobile application, right? So for this, there are certain things which you will find little bit, as I'm an offensive security guy, but I will be discussing about the risk analysis and all. But these are the regulatory requirement. You cannot avoid these things. Without things, it is very hard to sell the products into countries like US and all, where they ask everything. The questions they ask, it's amazing. If you talk to FDA guys, how you need to maintain the medical devices. And if you see, there are a lot of NIFT documents and FDA documents are coming online. Just they are discussing about how you need to secure your medical data. So I think my laptop charging is going. So can I just take the charger? Gayatri, can you give me the charger? Stuff bag. So I have the charging, but in between it should not stop this. Why? Sorry. Don't worry, I will finish on time. So yes. So firstly, when you are pen testing any medical devices or the applications, the first thing that you need to do is gather as much as public information you can. Is the one of the beneficial thing that you can do to pen test and to know about the bugs inside your application or the devices. Second, that is a very important thing. Just it has to have the more focus, because the uniqueness in medical devices is workflow. How one application talks to another application, and what are the protocol they follow, how they communicate, and because this thing is very different also from other kind of pen testing. So the these applications or devices, they are very complex, they are very huge. If you see, if anybody is developing the X-ray application, they might see it's a millions lines of code, and the functionality there for each thing, you need to have this, you need to have that. Because I pen test these devices and applications, I know how much time I just give just to understand the application or the device. And if you are a manager of any company who is doing the medical device pen testing, then give more time to the pen testers. Because I'm a pen tester, I have to ask my managers, just give me more time, because I need to understand the flow. So that is very important. Threat modeling is a very important part. I'm not talking about the threat modeling from the initial phase, but I'm telling from wherever you can just do that. it will find the sometimes very specific vulnerabilities that you might just miss when you pen test the standalone system or the application. Again, for every device, you need to have the specific test cases. Just understand the application, you need to have specific. It's not like you have a web application, mobile application, just follow these test cases and can be done. No, that's a very wrong approach if you do that. Again, this risk-based analysis and risk-based pen testing I have written because these are the questions that were asked by the FDA guys. That how you are doing the risk analysis, where is the document, how are you reporting it, and the vulnerability you are giving, how you deciding the risk and everything else. So that is why I have kept these things. So the approach, if you see in the medical devices, pen testing is a bit different from the normal one. And give more time in understanding the the application rather than directly attacking the application, right? So yeah, so these are the things. This is the methodology you need to follow. Now, what kind of attacks you can do on the systems? If you go to the hospitals, you have technicians, you have admin, you have nurse, you have doctors, you have some other level doctors. So sometimes in a single application, you have multiple user roles. If you are a pen tester, offensive, just go ahead with the user privilege vulnerability very specifically. I'm pretty sure you will find a lot of bugs. So if you see the X-ray or ultrasound machine, these applications are very big. They are also very hardened in a way. If you have a X-ray machine system or some other imaging modality system, they will provide you access only to the application. You will never be able to access the underlying file system unless there is a specific authentication or some kind of third-party authentication is provided. Just for the specific purpose, a normal technician cannot access those the file system. So when you have so these systems are very hardened and does not provide any kind of, sometimes I have seen the system, they don't provide you pen drive access, you cannot have any kind of again file system access, and any just application, it will be just an application, enter the application user and password and access. We have got I have seen something, this, if you have a Windows system, just try the Windows feature like sticky keys, hyperlinks. You might find a way to get into the file system. So file system, again, if you are using a secure communication, DICOM communication, and if you have a file system access, then your certificate is exposed over there. Generally in medical, if you have implemented a certificate-based authentication or authorization, it is always a two-way trust. So you might find the private keys as well. Again, this is very funny, monkey testing, but in some of the things, this was the best thing I did. You know what's the monkey testing? Just press the key, right? So I did that actually, you won't believe it, but I did that and I bypassed the authentication of the application. So in one of the product, it took me 1 or 2 days just to find out what I have pressed, how I bypassed the authentication. Just to get that shortcut, I spent a day or two. So it worked for me. Might work for you or not, but yeah. Look for writable directly, in a sense. You are not, as a normal user, you are not allowed to, create files, write into files and anything. But you might be able to find certain directory where you can write it. You will not have the privileges to run command prompt or to open the PowerShell, execute the commands. Look for writable directory and find what are the things installed on those systems. You might find a way to bypass that restrictions. Full understanding of the application, as I said, this will help you to find many logical bugs. This is my favorite part. So whenever I get any device for pen testing, this is my favorite part, and I always find good bugs using this technique. Command injection. I'm just saying it, but if I'm saying it, there might be some reason. Just focus on this one. USB configuration. So some of the devices, medical devices, you see the configuration or the upgrade happens using the USB. You might have XML file, you might have the firmware. Focus on those things. You might be able to do some interesting things. Custom services. So custom services, why I have written this? So when you have a modality and pack server, for different purposes, they use the custom services. They design the services, the exe file that you will never see. But if you are running an application, they will be running at the background. Now, if you see you have a custom services, they are just written by the developers. And I can say most of the times those services, those EXEs are never checked for any kind of vulnerabilities. They might be using some very old, vulnerable function, C function or whatever technology they have used to create those EXEs. So this is the very gray area, I would say, that a lot of pen testers never focuses. And they just get the system, work here, there. And the one more reason is why they cannot focus is the environment. It is very hard to get a hospital-like environment. Generally, if you have a device, you will be doing the pen testing of a standalone device. And if you are doing the workflow as well, then you will be using some kind of simulators that will be running inside the, that will not provide this kind of services to you. So this is a very, very, I would say very, I think the custom spelling is wrong, right? Yeah, my bad. So again, cloud. So now because you see the patient data is not available to the hospital only. If you have some problem, your data can be shared within a few minutes from one country to another. So because of that, they are using cloud, web, and these kind of technologies. So those also comes into the healthcare securities. You check for cloud services, their vulnerabilities, and from there you can get hold on to the patient data, and you need to close those vulnerabilities so that it will not be revealed, right? So I think it's clear, right? Or you have any confusion in this? No? I think I'm not boring you guys. So we have talked about DICOM, its workflow, services, how it works, how in hospital it works, medical devices, what kind of medical devices are there, what approach you need to take, what kind of most common vulnerabilities. So I'm not saying these are the only vulnerabilities you can find, but these are the very obvious vulnerabilities that you could look for with more focus. So yeah, let's talk about securing these things. Of course, the first one, encryption. The data at rest should be encrypted and data in transit. But in hospital, if you see, there are certain areas where you cannot implement certain kind of, SSL-based communication, because let's say emergency ward, right? Patient came in emergency and the patient information needs to be transferred to the ICU or to the doctor, the emergency doctor. Now, just because something SSL is not properly implemented or because of the error, your information is not going to the right department, right? Just because of your secure communication, you are not able to send the right information at the right time, and suddenly, because in emergency, anything could happen, right? I should not say, I just don't need to say you that the patient life is at the risk, but it is. So in that case, hospitals takes the exception that I do not want any kind of trouble over there. I just need my data to be present here, just to diagnose the patient or to cure him. So these are the loopholes when we look at the cybersecurity world. But in general, some exceptions are there. Yeah, DICOM, the PINet DICOM, where portable executable are inserted in a legitimate DICOM file. That attack can be mitigated just by removing the, can be mitigated somewhat by removing the headers, the initial header, right? Preamble where the guys added the DOS header and all. If you remove that header before processing the image, then it will be secure for somewhat. Because as I said to you earlier, .dcm file, if you open in a DICOM viewer, it will be open perfectly fine unless you are changing the extension or opening it via the command prompt. Then it will execute. So if you remove the header, then it will be fine. Again, authentication. For every data, for every patient data, you need to see who is accessing that data. Whether the patient really needs to see this, whether the person who is seeing the patient data really needs to see this data or need to modify the data. Like when we talk about the modification, we never give privilege for a nurse to modify the data, right? She is just to see the information. She is never eligible to modify the data. Modified data is always in the hands of doctor, the experts. So those things, those privileges needs to be implemented properly. Authorization, there are certain things that should not be accessed by even a nurse or technician. They don't need it. Like workstation, means you might have certain areas where you don't want this information to be shared with the lower level guy. So, but if you do the pen test, you might find certain bugs like this, that a nurse will be able to access this functionality or that data of a patient. Yes, so authorization should be properly implemented. One of the bigger problem in healthcare industry is the, if you see, is the upgradation. So devices in healthcare, most of the devices are legacy devices, and they're costly devices. It's not easy to upgrade. So I'm a security guy, offensive guy. I can come here, I can say, hey, you have a vulnerability, you need to upgrade it. But they have paid millions for that single product. I cannot go and say directly. So this is the biggest problem people right now are facing. If you see the standard, most of the device supports HL7. Now they are migrating to FHIR. They are using the legacy system. They have a mediator which converts the FHIR data to the HL7 and HL7 data to the FHIR. So you cannot easily, so this is one of the problem, that upgradation is a bit difficult in the legacy devices. Software patching, again, it is not an easy task. So if you have and you find any bug in the software or a OS, then before, you cannot directly go ahead in medical devices and you can push the update. No, it has to be fully analyzed in a environment, in a very controlled environment, because the functionality might get disrupted just because of your update. Anybody has faced this issue? You have updated and you got some problems, right? Sometimes you faces. I faced it in mobile phones or in some operating system where I updated the operating system, and because of that, some of the functionality was not working, or the other software that I'm using, that was not working. No hard-coded secrets. If you are using IoT, because medical device makes use of IoT devices which has hard-coded secrets, like sending the data to the cloud. So they hard code sometime they plainly hard code sometime the secrets or the I would say the encryption key, the password directly into the firmware, which can be easily extracted, right? IoT guys, firmware reverse engineering, right? It can be easily done. Input validation, vulnerabilities like OS command injection and XSS. These are things just because of you are not properly, validating the inputs. This is happening just because of this one, OS command injection. So you need to validate every input you get. And when I do the pen testing, we always say that never trust the end user, right? Whatever dynamic parameter you are getting, never trust that. Always validate anyhow you can. The last one is the SSS tunneling. This is my this I personally suggest, because if you are in a hospital, you cannot afford the certificates and all, you can properly implement SSS tunneling. Only 2 ports will be open at the backend, that is 22. The attacker will never get to know what kind of services running over there and what kind of data is being shared. So if you have properly implemented SSS tunneling, this is my personal favorite. It stops certain kind of attacks. So it's very nice. Yeah. So these are some of the mitigations you could take to secure the DICOM or the medical devices. So last, I would like to thank you, my Philips. I'm a part of Philips Security Center of Excellence, which do the pen testing, and they have reviewed my slides and always helped me. Special thanks to Abhishek Vivi. He's a member of my team for helping me in preparing the demos. So yeah, that's all. So I think I have 2 minutes. Any questions?
Thank you very much, Ajay, with the exception of Altaf. Any questions from the floor?
Altaf is not here. Yes.
No questions from the floor. Let's look at the Slido questions. I think the highest voted one with a strong 8 is, how will you test this DICOM standard in HL7? Any particular tools?
How will you test this DICOM standard in HL7? Do you have any specific tools? Go back. Yeah. So for DICOM, I think I have explained all the scenarios that you need to take. Firstly, it's a simple DICOM image file. It's a standard. For pen testing, the only thing that you need to have is the certain kind of client and server things which you need to have, like Pinet DICOM is available. The main challenge that you will get in DICOM standard is having the devices or the server where you can pen test, which I think most of you have faced. So there is, I will not say there is a specific tool. If you have the tool, they will just create a file for you and will give you the file. But mainly it's just a Pynet DICOM library you could use, which I have used, where you can create the client and server and check the packets, what kind of information goes, analyze those, and once you have the DCM file, you can see how you can modify the image and all that you can do. For HL7, again, HL7 is also a standard. DICOM is used in imaging devices. HL7 is normally used with static data. It's the same plain text file. It's a plain text file and makes use of TCP to send the information from one place to another. It has the same kind of format like DICOM. I will not the same, but it is again used between the two devices just to have the common language. So there are certain tools which I believe they do have. You can have the HL7 messages. You take in that tool, you modify that. So HL7 test tool is there available. You can use that tool, get the HL7 message, send it to the server by having the server configurations. So you just need to check the dynamic related vulnerabilities, change the parameters in the HL7 message and send it. So these kind of things you can do.
Thank you. Before that, may I just have an idea who Doctor Who, show of hand, who asked that first question? Anyone from the room who asked that? You have a gift waiting. Anyone could have raised your hand, you know that, right? Okay, we'll move on to the next question.
DICOM mistakes look like a buffer overflow attack based on logs, and this type of attacks prevalent in yes. So I think it's not a question, it's a suggestion. So buffer overflow, if you see wherever there is a parameter, you assign some buffer for that, and if it is not properly handled, it will lead to the buffer of overflow attack. So definitely, it's not in the medical devices, it could arise anywhere where the data is not properly handled. And if you are making use of any platform based on the platform vulnerabilities or exception, it might directly leads to use the remote code execution and directly throw back the reversal if a specific version of the operating system is being used. Yes, that can be. It is possible. Yeah.
I think that's all the time we have for question, in fact.
Okay, so
who is the one who asked that question? Anyone? Okay, great. Wow. Such an honest audience. Thank you very much.
Yes.
And thank you.
So that satisfies your question? Cool. So I think if you have any question, you can ask me offline. So my time is up.
I'm happy to take one live from the audience if there is anyone. We'll skip the Slido. Any live ones? No?
Live question, any? Yeah?
No?
I think the presentation was pretty much good. No questions.
Ajay.
Yeah.
How many times it happened to you to pen test this kind of scenarios environment? I mean, at that kind of target, because I began pen testing hospitals back in 2004 or whatever, but it's the first time that I encountered into this protocol. So what I want to ask you is how often the clients asks you specifically for this kind of deep and not for the boring pen test like hosts, IP, and so on, but to get into the protocols.
Yes. So in generally, you will never have access to the hospital where you will live do the pen testing, but you can create the hospital-like environment, which we do have. And which we also perform the, we have the event where we create a hospital-like environment. We check the workflow of the application, and there we lively do the hacking and try to find a way to hack into the systems. But that is the benefit that I have because it's a healthcare-based industry. They make the products, and I have access to this information. But the normal service providers, medical device pen testing service providers, they generally don't have this kind of environment where this is the place where they are lacking for checking the workflow related issues. So yeah, your question is absolutely correct. Yeah. I think we need to give him the audio because nobody else is there.
Excellent. Thank you very much, Ajay.
Thank you.
That was a really interesting talk.